Thank you all for coming to the Autodesk Awards 2023 today. Before starting the presentation, I would like to express our sincere appreciation and gratitude to Autodesk Reward about receiving this award. And change of plans because the names are changed. And my name is Andy Siu instead of another kid, and I'm a BIM engineer from Shui joint venture. I'm going to be the representative to be one of the award winners to present the BIM implementation of our construction project. I would like to introduce the name of our ongoing project, which is named as the Drainage Service Department Office Building at Cheung Sewage Pumping Station. It is a design and construction project of a 21-story government office. Although we have many BIM implementation, like the coordination or other stuff about the implementation of the BIM, but there are two exceptional I would like to introduce of how we utilize the BIM adoption for the benefits of our construction project. And the first one is about the coordination of the existing trees and temporary hoarding. And the second one is about the prefabricated steel reinforcement with BIM adoption on the bar bending schedule. And the first one will be about the trees and hoarding. Temporary hoarding is not much a big issue if all the roads are flat, as we know. However, there are trees. Trees are always going in the shape that you don't expect and may not be permitted to remove or trim for the construction project. Before any installation, we have to conduct a survey to know what is the actual situation. The traditional method of surveying can only get an abstract height as for the reference, and it doesn't help you understand the full picture of the shape unless it is in the spherical symmetry. As a result, there is difficulty in accurate measurement of heights and shapes. Cameras and ladders may be involved, but they shall lead to some safety risks in conducting the survey. Also, the process is very time-consuming, especially when the size and the quantities of the trees are large. Any miscalculation can lead to some potential works of removal or modification of errors, resulting in wastage of material and cost overrun. Rescheduling of the labors and the works can lead to some extra costs and delay the program, which we don't want to have it happen. Besides, the procedure of obtaining the permits on working outside the site area usually takes days before the actual works, and especially for this project. The primary school is located next to our site, so it basically more concerned on the actual schedule of the works, because we have to have some communication to the principal of the primary school to not disturb the daily life of the students. As to solve such issue, laser scanning is adopted. In this case, practical laser scan from the Leica is used. This is a 3D mobile laser scanning from Leica. You can see show the live data in the connected application from the Leica. And here is a brief of the workflow. It starts from using the device to import the data to using it in the Autodesk Revit. At first, we start up the device and scan the designated areas. We just hold it up and walk. You can see this is a screenshot of the live data shown in the mobile app. And then the file is extracted from the device and modified from the Leica application and exported to a special file format, which is called PTS. It is a commonly used format of the point cloud files. And then the PTS file is imported into the Autodesk Recap. Here you can delete the unnecessary points like the cars or the pedestrian. At last, it is exported as a RCP file. And then you can see this clear picture of many ponds showing the trees, the streets, or other objects you can find by using the scanner. And then we can finally visualize the relationship between the point cloud file and the 3D model of the intended design, like the hoarding. And different views can be set up easily to carefully check if there's any design flaws. And here are the photos of the sheet to show that the difference before and after the installation of the hoarding. Without doubt, the method of using the Leica protocol to scan streets and trees is extremely easy to be executed. All it takes is just starting the device, walking through the street, and we want to scan. The scanning can easily be done under 10 minutes in one take if there's no one intentionally interrupt us. Even if there are cars or the pedestrians walking past us, we can still edit them out in the Autodesk recap. The scan range is fine enough so there are no needs to come up anywhere else to scan. The following process to import the PONCA file into the design model of the temporary hoarding is extremely easy, as I have just shown in the previous slides. All can be done under an hour. Unlike the traditional method, the PONCA file allows us to visualize the whole shapes of the trees. We can just check all the angles in 3D views and make a correct measurement of the size and shape of trees. With the imported PONCA file, any parts colliding with the design can be immediately visualized and understood for further modification. The cache can be solved before the actual installation, improving the performance of works in cost and safety. And as for the second one, it is about the prefabricated steel reinforcement with BIM adoption on bar bending schedule. As a fact, prefabrication of the bars relies heavily on precisions. However, the traditional method of the calculation is comprised of manual calculation by laborers and human interpretation, and based on 2D drawings only. Lots of mathematical formulas and tables are involved for the calculations, and this calculation can be very complex and time-consuming, especially when dealing with intricate structural designs or multiple rebar sizes and configurations. Depending on the scale, design, and the schedule of the project, the difficulty for the calculation can be scaled up. And usually, there are design changes. In the fortune case, you can make some small adjustment to the mathematical formulas and save the time. If not, congratulations, you will have to calculate everything again. Due to the miscalculation, the amount of works, including the logistics, the works of on-site cutting and bending is increased. Wastage and extra costs on materials and labor are caused as a result. Also, the increased amount of works cause more exposure to the safety risk. For example, hazardous byproducts generated by on-site cutting and bending of rebars can pose health risks to the workers. As to solve such issue, BIM has been adopted for the bar bending schedule. Here is a brief of the rebar bending schedule workflow. It starts from the BIM model from the Autodesk Revit to the delivery of prefabricated rebars to site. As first, we receive the latest drawing and produce the BIM models of rebar in Autodesk Revit. Then the clash detection is performed in the Lavage works to find the unknown clashes, which helps confirm the designs and flaws with fixers and engineers. After that, the bar bending schedule will be exported from the Autodesk Revit directly. It provides the detailed information of the reinforcement bars, including the dimensions, shapes, and quantities. And here's an important part about that. We use the add-ons of the Sofitex. It's used to export the ABS file. The ABS file contains the same information as the bar bending schedule, except there's some raw data in the text format to be distributed to the reinforcing bar prefabrication yard. It is worth to mention that these ABS files are under the standard format from BVBS guideline data exchange of reinforcement data. It is a standard of rebar details from Germany, and it is commonly used in Europe and many Asian countries, including Hong Kong. The ABS file is then imported into the rebar bending schedule software, the Snell Graphical Pro, and production tests are generated for the fabrication. The tests are scanned via the barcode scanner to input the product attributes and start the automation of the rebar fabrication. And at last, the fabricated rebars are delivered to the site. The adoption of BIM in the rebar calculation process brings great benefits to the whole prefabrication process. First of all, BIM provides precise and coordinated 3D model of the structure, enabling a correct placement and alignment of rebars. The visual representation of the rebars allow better understanding and communication among the stakeholders of the project. Then it provides the function of the cache system to automatically discover any unknown cache to the structure itself and other building elements, including architectural, mechanical, electrical, and plumbing elements. And adjustment is easy to be made to the rebar components in BIM models and proceed for same change automatically to the same types. Time is greatly saved when there are any design changes. And as a result, the precise calculation minimizes all the possible errors, saving time and cost in each part of the rebar process. Quantities are better calculated to improve the logistics of rebar delivery and storage for congested sites with insufficient space for bending yard. Amount of works are minimized and quantity control is enhanced, improving the construction safety in general. Productivity and the build quality of overall project completion are greatly improved. And this is the end of our presentation. Thank you.